Hello, my name is Arthur, and in this video we're going to look at click to move to get this tank going around the map. So first off, we'll look at some of the additions to the tank. Now, I've re-imported it in the correct orientation, so now it's facing the -C direction. And when I was re-importing, that gave me an opportunity to lump the treads in with the chassis instead of having a separate scene for the tread animation. So now I have two animation players, one to play the wheels and one to play the treads. And I don't know, possibly that could have been consolidated in Blender. I'll have to look into that to see if that's possible. So I've just rebuilt the tank in the new orientation. I've added in a position 3D node that is right there, and a raycast that is pointing down. So it's casting down. For some reason in 3D, raycasts don't seem to show up. Like I can never see the raycast, but it's there. I placed it under this wheel, and its purpose is to detect floor normals and orient the tank according to floor normals. So we'll just have a look at what it can do, and then we'll look at the script that's making it do it. And because I'm not that great with 3D yet, I've spent most of my time in 2D. I can't really write script on a video, so the script's already written. So it can turn towards its direction. It tilts on the different angles of the floor. And unlike a lot of examples of point to move, it's not going to instantly face the direction you point in. It turns and drives towards that direction. So that's it. It doesn't look like a lot, but it took a little bit to figure that out. It has some issues. It seems to bounce when it goes onto a hill. And yeah, I'm not really sure what that's about. But it has a little bit of odd behavior that probably would be resolved by not having such simple hills. Like this hill is made out of 4 faces. It's just a cube stretched around. So that would probably help. And yeah, it's just an object to stick into the scene to get the tank working in the first place. So how well the tank acts on this particular object is not that important. So the world script hasn't changed at all. It's kind of taking the hard way of getting the location of the mouse click. There is an easier way to do that, but that way involves signals. So yeah, I'm not sure exactly how that plays out if you're doing something like adding in a bridge that the unit could drive on, because then you'd have to script in the signal addition as well, and I don't even know how to do that. So there is an easier way to go about this if all of the surfaces your vehicle can drive in are already going to be in the scene tree to have the signals hooked up. But when I can, I avoid signals, and if it takes doing things the longer way to avoid a signal, I'll do things the longer way. So this is just doing exactly what it was doing before. It toggles the selection of the player select bubble to be true or false, and sends the click position to the unit. So everything is really happening in the tank script. So there's a number of constants. They're pretty typical for a vehicle kind of unit. So we have speed, turn, gravity, and the destination radius. That's the space that the unit has to make it within to cancel the destination. Then it has the destination and velocity variables. The function selected, that hasn't changed. It just toggles the selected mesh so that the green bubble turns on. Set destination, right now it's just destination equals the target, which is the position sent from the click position. So in physics process, where everything starts, the first thing I do is I store velocity y as a temporary variable so that I can zero velocity and not have speed accumulating. So speed is not additive or accumulative. If there's a destination and the distance to the destination is greater than the destination radius, so it still needs to travel to the destination. It will check if the animation player is playing. If it's not, then it will play. That way it doesn't continually go animation player play, oh, I'm already playing. Then it does the movement, which is velocity plus equals minus transform basis z. So that's the reason that I reoriented the tank so that it's facing minus z, because I guess this is the standard direction that things in Godot are supposed to move. And then we're times speed, and speed only equals 1. And speed is pretty small because the tank is pretty small. The same as the destination radius is pretty small because the tank is pretty small. Then it gets direction. This is where I avoid using the look at function to simply have the tank turn in the direction of the click. What I do is I have the compass look at the destination, and then I use the compass rotation degrees, which is relative to the tank. So if the compass looks on one side, it's looking to a negative. On the other side, it would be looking to a positive, because the front of the tank should be 0, as I understand it. So what it does is if that direction is greater than 5 or less than minus 5, that avoids any divide by 0 errors, and it stops the tank from jittering. If it tries to turn to the precise angle, it will start jittering. So we divide that angle by the positive. ABS direction can never be a negative. So that will result in either a positive 1 or a negative 1. So if it's at a negative angle, it will result in a negative 1. If it's at a positive angle, it will result in a positive 1. And then I simply use rotation degrees dot y plus equals the direction. So positive or negative 1. And that does the rotation. A lot of the reading that I do for 3D movement, it kind of wants for us to avoid using this kind of rotation. But because of the nature of this kind of game setup, it's essentially 2D. And most of the movement that's happening is 2D. So this kind of rotation should not be problematic. We're not going to get gimbal lock or a bunch of confused angles as a result of that. And yeah, the turrets will be rotated in a similar fashion, except they'll be set up so that, well, they're already set up so that we're only going to be rotating certain objects in one direction. So they'll only ever rotate in Y, and for up and down, It actually will be a different object rotating in one direction. So they're kind of automatically have, I think it would be called a gimbal built into the way that the tank is built. Because in the case of the turret would rotate to point on the Y angle. And then the main gun would rotate up and down. So each thing will only rotate in one direction, and that is simple enough to be able to use that kind of rotation. And I don't know another way to go about it. So that's how get direction works. So else destination equals null. That's if there is no destination, then destination equals null anyways, and these aren't doing anything. Or if the distance to has become equal to or less than the destination radius, then get direction will be cancelled and it will stop moving. And yeah, this will kind of get changed, and we'll look at how we're going to change that depending on how long this video takes. And then the gravity is added back in, recalculated, and velocity move and slide happens, where I've set stop on slope to true so that if the destination is on a hill, it's not going to slowly trickle down the hill. Then this part here this is directly from Kids Can Code. I can try to explain it, but Kids Can Code does a tutorial for aligning a kinematic body to the surface. So this is what gets it to tilt on a hill. So it checks the collision normal of the raycast, and if it's on a hill, it's going to return the collision normal of the hill. Then it uses a function right here, align with Y. What this function does is it makes it so that the tank Y doesn't just attempt to meet up with the floor normal, because that isn't enough. It has to also be adjusted on X in order to properly align with the floor normal and not be able to not be skewed. So this uses the cross function to angle Y properly by also giving an adjustment to X. And that's difficult to explain. I barely understand how it works myself, and the best explanation you'll get for this would be from the Kids Can Code tutorial. And yeah, I'm just happy to find such good tutorials to be able to get things like that working, because a vehicle doesn't look right without this kind of a function. And yeah, and then this part interpolates so that it doesn't just instantly become onto a different angle. So when it goes over a harsh change in angles, it interpolates the change in angle a bit. So yeah, that's what I have working for the tank so far. It kind of seems like a lot, but that's kind of what it takes to get a vehicle to look like a vehicle in a click to move situation. It has to kind of drive like a vehicle. So most vehicle tutorials are going to show how to drive a vehicle with keys. It takes a little bit more to get the vehicle to be able to drive itself to a destination and not just do the instantly turn towards that destination and actually have to turn to drive it. So let's see how much time we took here. Okay, Okay, that's 14 minutes, so I'll come back in another video and we're going to change the click to destination and how it gets canceled out. So we're going to make it so we can select the player, give it a destination, but he's going to stay selected until we left click. And we're going to make it so that a destination marker appears here, and we'll be able to click a second destination marker and a third destination marker and outright draw out the tank's path and have it collect the destination markers while traveling that path. So that'll be in the next video, and until then, take care.